Hello everyone. In this tutorial, we will be learning about Numpy, which is one of the most extensively used Python library. Numpy has found numerous applications in mathematical operations involving linear algebra, Fourier transform, matrices, and arrays. So basically, Numpy is nothing but a library which has a range of fast and efficient ways for creating and manipulating a large amount of numerical data sets. NumPy arrays are they're more compact and they occupy less space and hence they are computationally fast. As a result of which, NumPy has been preferred for various complex simulations as well. So now, what exactly is a NumPy array? This is quite similar to a Python list, but the main difference between a Python list and a NumPy array is that in the Python list, the data type need not be homogeneous. That is, a Python list can have both a string as well as a numeric data input. But in case of a NumPy array, the data needs to be homogeneous. That is, it should be a numeric input. So now to begin with NumPy using Jupyter Notebook, first we have to make sure that the NumPy package has been installed in your system. So usually if you install your Jupyter Notebook using Anaconda, there is a very high chance that NumPy is already installed in your system. But in case if it is not installed, there is nothing to worry about. Just open Anaconda prompt like I just opened and type conda install NumPy. So in my system, NumPy has already been installed, and so in the end, it is going to show that the package has been installed. But in case in your system it has not been installed, it is going to start the installation. So now, upon doing this, next what we are going to do is that we are going to import the installed package into the Jupyter Notebook. So like as you can see here, the package has already been installed in my system, so it's going to show something like this. So I'm going to close this window and I'm going to import NumPy as NP. We use a short form so that every time we use the syntax, it is not mandatory that we spell out the entire name. So I'm going to execute that command, and now let us begin with creating a very simple array, which the command for that is numpy.array open simple braces and then square braces, and I'm going to just start off with something very simple and very basic. So I have created a list of 6 digits and I'm going to store it as an array, and let's just run this command. And now if you want to see a, it is going to look something like this, and this particular array is stored in NumPy like this. Okay, now accessing individual element in an array is quite similar to how we used to access individual elements in a Python list. So now if we want to access the first element of an array, we type a of 0, or if we want to access the first 4 elements of an array, then we type like this. So as you can see, the accessing is quite similar and quite simple to what we used to do in a Python list. So along with this, NumPy has various other advantages like creating an array of just zeros. We just have to mention how many number of zeros are needed in that particular array. So now let us say I want an array with 4 zeros in it, and I will also try to create an array with 5 ones in it. Okay, so now let me print x and print y. So as you can see, the program has actually generated an array of zeros and ones, and the number of elements in these arrays are same as what we have given them as an input. Another way of creating an array is a command using np-arrange, wherein it actually creates an array consisting of numbers starting from 0 until the number we have specified, that is in this case it was 5. Okay, and another application of this command, that is np-arrange, is that we can actually mention the upper limit and lower limit of the digit as well as the spacing between the individual elements of the array. So here our starting digit is 2 and the ending number is 9, and we want it to be spaced. Like the 2 should be the spacing between the digits. Another very extensively used command is np linspace, and I am going to give it a 0, 10, 6. So what exactly this means is that we want the numpy to create an array wherein the numbers in that array is greater than 0 or equal to 0 but less than 10, and we have to choose 6 digits between 0 and 10. So numpy is going to give us 6 digits between 0 and 10. Now if we, in the same case, if we make it as 5 instead of 6, we have 5 digits which have been picked between 0 and 10 by numpy. So now let me just create another random array just to show what all numpy is actually capable of. I'm going to punch in some random numbers: 4, 8, 2, 6, 1, 0, and 7. Okay, so now we have an array which consists of random numbers, and so now if I just ask this to type, it's going to say this is how the array looks. But I want my array to be sorted in the ascending order. So then we have a very simple command. We just have to write numpy.sort array, and we have it all sorted. Now, similarly, let us say we have a Python list and we wanted it to be converted to array so that we can use it in other operations as well. So, I am going to first create an empty list, or a list of people and their height. So, let us start with 1.6, 1.8, 1.7. So, this is the list consisting of height of 3 people, and just to make it clear, I'm going to type of the variable. So it says that the variable height is actually a list. Now I want this list to be converted to an array. So I will say ht is equal to numpy dot array open simple braces, and within the simple braces we just have to mention the variable name. So now if you type of ht, you are going to say that it is an array. It has been converted to an array. So after having done that, now there are various operations which we can perform involving arrays itself. So for that, let me just create 2 simple arrays, 1, 2, 3, 4, and 5, 6, 7, and 8. Okay. So now I have created 2 arrays consisting of different digits. In case if I want to add these 2 arrays, then there is a command called numpy concatenate, and that we can actually do it as a comma b, and we have it here. So if I type it, it is going to look something like this. So now here we saw how one-dimensional array gets stored. But how about n-dimensional arrays? So now this is just for an example. If we consider 2 lists, that is 1, 2 is one list and 3, 4 is another list, it is going to get stored row-wise again. Now let us consider an example of a multi-dimensional array, which we can also say how the matrices are actually stored. So since this is an example, I'm going to term the variable name as ex numpy dot array open simple braces. I'm going to open another square braces and another 2 square braces. I'm going to tell you why. So 0, 1, 2. Okay. Now there's another comma, and I'm going to go with 3, 4, 5. Okay. Next, I'm going to, so this will basically become your first row. Okay, so now again I'm going to open 2 more braces, and I'm going to just punch in some random numbers. Okay, so again we have one more, and again I will just give something in random so that we have I think we got them all. Now I have tried to create a random multi-dimensional array, and let's see how it's typed. So now here, or in this case, how this array is going to get stored is in place of 1 comma 2, what you can see here, we will have 0, 1, 2 and 3, 4, 5, and same way 5, 6, 7, 7, 8, 9 and 0, 5, 6 and 6, 3, 8. Now, if at all, because it's a very simple example, we can actually visualize. But in case if it's a very lengthy array, then usually what we do is that we use different set of commands in order to determine the shape. So now let us try to find out what is the dimension of this particular example array. So we use a command called as ndim, which actually tells you the number of dimensions, which is nothing but number of rows in the array. Now there is another different set of commands as well, like ex.size, which is actually going to tell me the number of elements in the array. And if I want a general complete dimension, which we will call it as ex.shape, that's you're trying to determine the shape of the entire array, then it says that the entire array consists of 3 rows, 2 columns and 3 elements in each particular, what you can call it as blocks or the data allocation point. Okay, so now sometimes we if we have a very lengthy array of more than 10 or more than 20, and if you want to reshape it, it is very simple. But for that, first let us create an numpy dot arrange, and I'm going to create a very lengthy array for that matter. So I'm going to go with 0 comma I think I'll give around 50, and I will give the spacing as 2. So now if you check out X, it is quite lengthy and it is very difficult to visualize do further processing. So in such case, what I'm going to do is that I will use a command which we call it as x dot reshape. That is, you want that particular array to be reshaped into let us say 3 comma 4. I'm not sure if it is possible. Let's just try. Okay, there seems to be some problem. Oh, I will have to reshape it into equal size. So for that, let us just find out x dot size. It says it has 25. So that was the problem. You cannot reshape an odd number into a number of elements. So what I would do is I will just change it to 51 and I'm going to run. So now I have 26. So automatically I can reshape it into 2 rows with 13 columns each, or we can make it even more simpler, and we can try to reduce it depending upon the number of elements that exist. Okay, so now in the same way, just like how we reshaped, now we can also do something called as indexing and slicing. Now coming to indexing and slicing part, let us say we have actually created an array X here. So I am going to ask program to print, let us say X of X greater than 25. What I want this command to do is actually print the elements in array X whose value is greater than 25. So you can see it is going to print us a list of numbers like that. Similarly, we can also print out a list of elements in X which are actually even numbers. For that, I'm going to use the percentage symbol and give it as X whose remainder should be equal to 0. Okay, so if I do this, I think, yeah, I can get the number of even integers in this, And in the same way, we can also use logical operators such as and, or, and so on. I'm going to show a simple example wherein we consider and a greater than 1 and a of x, and I will give x greater than 10 and x of x less than, I'll go with 30. Okay, so now, okay, I think I have made a mistake because I did not use this, and this is not needed, and here we need a square basis. I think that should fix it. Yeah. So here we were trying to find out only the list or an array of those elements whose values are greater than 10 and less than 30. So like this, there are different operations that we can actually perform, and also we can access. And one more important thing is how you can slice a particular array. Now for that, I'm going to create two subsets from this array X. Okay, so now I will consider the first 10 elements as array 1, and in array 2 I am going to consider next 10 elements, and this is going to be array 2. So now if you try to find out what is array 1, it says like this, and you can also find out array 2. So automatically the original array, which was actually x, has been split into two, that is array 1 and array 2, and there is still a part of x which has not been extracted. So like this, you can also split or slice a certain part of an array and store it separately. Now that we have extracted a part of an array in array 1 and array 2, let us see if we can combine these two. So there are two ways to combine other than the concatenate operation. There is something called as horizontal stack and vertical stack. Now I will try to create a new array wherein I'm going to use the command horizontal stack, and I will write it as array underscore 1 comma array underscore 2, and I will give it as new array, and as you can see, it has created like this. Now the same command can actually be used for vertical stacking. I will copy the same set of command but with a small change. Okay, and in place of h stack I'm going to use b stack, and I'm going to click, and you can see here this has been stacked vertically. That is, for when you say horizontal stack, the two different arrays are getting stacked next to each other, that is horizontally, and when we say vertical stack, the two arrays are getting stacked one below the other. So that is the usage of horizontal and vertical stack. So here these two commands are basically used to combine the two arrays in whichever fashion that we need. Now in the same way, we can actually split an array as well. Okay, so for that I will create a new variable, and I will give a command as numpy dot h split, that is horizontal split, and I will say new array. Okay, so now if I just type this, okay, and I have to tell where exactly this needs to be split. That is, if I want this to be split after every fourth column or after every fifth column, I will have to mention that. So now I have told that it has to split after every fourth column. So let's see how it has come. So as you can see here, uh, it considers 0 to 468, then it considers 10, 12, 14, 16, 18, and so on. So basically it has split this entire thing into four different set of arrays. In the same way, I can use the same set of command, and I will say that it has to split for me for, and after fourth column, and after eighth column, and after 12th column. Okay, and let us see how this actually works. So as you can see here, again, if you want, we can give one more as well, just to maintain some symmetry, and you can see that it has created like this as well. See the difference between this command. Okay, let me name this as v. So the difference between the variable u and variable v is, here we said the number of arrays it needs to be splitted into, and in v we have told where exactly we want the splitting to take place. So now I can create another array which I want the array to be split at column number 18. So as you can see, the last two has actually come with only two elements. So like this, we can do different types of splitting as well. Next, upon successfully completing or creating an array, now one more important thing what we can actually do is that sometimes you want to manipulate a particular array. So you always create a copy and save it separately, or you create a copy and you manipulate the copied version. So in order to do that also, we can, let us say in this example, I'm trying to copy new array 1. So I will type it as new array 1 dot copy, and it's going to get copied, and it's going to be same as new array 1 dot copy. So this particular type of operations are extremely useful whenever we are trying to experiment, or we are trying to simulate something, and we are not sure about the outcome, so we take a copy of it and we try to manipulate with that. Now, coming to operations in array, this is quite similar to our matrix operation. So, for example, I have considered two arrays here, that is data and ones. So, let me just create it so that we can visualize this. Data is equal to numpy dot array 1 comma 2, and similarly I'm going to create ones is equal to numpy dot ones, and I want two ones to be created, and I want data type to be int. Okay, so now I have created two arrays, that is data and ones, and on this I can do any kind of arithmetic operations. For example, data plus ones, and it's going to be 2 and 3. So what exactly happened is 1 and 2 and 1 and 1. These were the two different arrays which I created, and I've tried to add these two. In the same way, we can also subtract and find out with a 0 and 1, just similar to this. And also taking the same uh, data into data, let me try, and then you can get 1 and 4, and if we take division of these two, we will get 1 and 1. So this is quite similar to our matrix operation. And one more interesting thing that we can do in arrays is that you can take a sum of all the elements in an array using the command data.sum. So it's going to say it's 3, because our data actually consisted of only 1 and 2, so 1 plus 2 is 3. Okay, and also numpy is actually capable of finding the maximum value in an array. In our example, it might not be so difficult, but when you have a very large data set, and these commands are really handy. And also we can find the minimum of a data set, and so on. Now we can do another interesting exercise with this, and I will create an array for that, numpy.array, and let me create a multi-dimensional array now. So let us say 2, 9, 7. I'm just creating a random array here, and 8 comma 3 and 1. Okay, so now I have created a random array, and I want to find a minimum in this one. It's very simple, it's going to say it's 1. But if I want the numpy to tell me the minimum in each row, then I give it as axis is equal to 0, and it says that it is 2, 3 and 1. That is, when you say axis is equal to 0, it goes column wise. So in the first column, that is, we have 2 and 8, so the minimum is 2. In the second column, between 9 and 3, the minimum is 3. And in the third column, it is between 7 and 1, and automatically it is 1. Now, if we want to find out the minimum value row wise, then we have to give axis as equal to 1 and then run it, and automatically you can see that in the first row the minimum value is 2 and in the second row the minimum value is 1. So this is some of the interesting observations or examples which we can use, so that these things come in handy when we are doing some complex mathematical operations. So now that we have created a multidimensional array, we can actually try to find the transpose of this using v dot transpose. But before that, let us just visualize how v actually looks. Okay, so now v actually looks somewhat like this. So what I'm going to do is that, let me just insert a cell and v dot transpose, and you can see that it is completely transposed. Okay, so now in the last I would like to show one very simple mathematical operation, so that you get an idea about how numpy arrays are actually used. Now, one of the most commonly used statistical operations or mathematical operations is finding out the mean square error, which is usually the sum of squares of the differences between the prediction and the observation. So now for that, I will first create an array which consists of a set of observed values, numpy.array, and I will say 2, 3, 4, 5. Okay, and similarly I will create another array which stands for the prediction, and I will create an array saying 2.2, 3.4, 4.1, 5.25 or 2, 3. Okay, now that I have created the two arrays, that is, one is for observation and another one is for prediction, I am going to write this formula using the commands of numpy. So I will term it as mean square error, and that I will give it as 1 divided by length of observed, because here in this formula it is 1 by n, where n stands for number of observations. So I'm just we can directly calculate n by using the command length of observations, and then into numpy dot, because we have a summation symbol, it is numpy dot sum, and then numpy dot squares, where we can use this command to take square, that is what we find here. So numpy square of, we want prediction minus the observation. Okay, so basically what we have tried to do here is, first we take the difference that is between prediction and observation, take the square of it, and then this operation is performed along all the elements in the list. So now if we execute this command, we will actually get the answer for mean square error, which is around 0.06572 and so on. So now here numpy.sum stands for summation, which we had already learned earlier, and squares stands for taking the square, and if you want to take square root, then the command is sqrt. Now apart from all these interesting things, there is one more very important application, that is to generate the random numbers in numpy. So within the numpy package also, there are numerous libraries, and random is one such library. So what I have done here is, from the numpy package, I would like to import the random library as rm. After having done this, I will try to generate a set of random numbers. So I will call it as random, rn, that is, I am calling the random as rn dot random, but it should be an integer and it should be within 100. So now if I take it, it is x. Now if I run this command again, I may get a different number. So that is the beauty of random, that is every time you run this command, you are going to get a different number, and you are not going to get the same thing. Now Apart from this, we can ask it to generate a set of numbers. Say I will call it as 2. So it is going to generate an array of 2 random numbers. Or if I want it to create a multi-dimensional array of size 2 comma 4, then it is going to create an array of random integers of size 2 comma 4. Similarly, we can also generate a random float numbers, which I will call it as rn.rand, and I want the float number to lie within 10. So now if I press Y, so it has generated 10 random numbers, that is the floating numbers. So this is also one of the interesting applications which we use mostly in time series analysis and signal processing. And I hope you have understood about NumPy a little bit from this tutorial. Thank you, and I'll see you in the next tutorial.